For exponential functions one-to-one property, the concept is if b is greater than 0 and b is not 1, meaning b can be any number, a whole number or a fraction, if these two are true, then b to the power of x is equal to b to the power of y. Then that means x, the exponent x, should equal to the exponent of y. Now, the reverse order would be the same. If x equals to y, then therefore b to the power of x equals to b to the power of y. Regardless of what b is, if b is the same on both sides, therefore the exponents have to be the same or equal to each other on both sides. So, for example, if you have 3 to the 4th power equals to 3 to the power of x, just like how we did in the previous section, if the bases are the same, then we have to set the exponents equal to each other, which is x equals to 4. And if we were to prove it, 3 to the 4th power, and then I'm going to substitute 4 into x, 3 to the 4th power is 81 on the left. 3 to the 4th power is also 81 on the right. These two sides are equal to each other, so it works. So by applying one-to-one property, one-to-one means that both sides are equal to each other, as long as the bases are equal to each other or the same. So another example where if it's not just x by itself. So for example, if we have 4 to the power of 3x plus 1 equal to 4x minus 5, then it's contingent where if the bases are the same on both sides, then therefore the exponents, let me rephrase, if the base on the left side is equal to the base on the right side, or vice versa, then therefore the exponent on the left side is equal to the exponent on the right side. So exponent on the left side equal exponent on the right side. Again, these right here are the exponents from the original example. And then therefore we can just solve using the methods we did in Algebra 1, Geometry, and Algebra 2. Solve an equation. So say I want variables on the left side, I'm going to subtract x, and I want numbers on the right side, so I'm going to subtract 1. X minus x will cancel, and then here I'm going to have 2x. 1 minus 1 will cancel, and over here I'm going to have negative 6. So 2x equal negative 6, and I divide by 2, so therefore x equals to 3. So by saying x equals to 3, so here I'm going to work out the left side. So 4 to the power of 3 times, that's my mistake, x equals negative 3 plus 1. So 4 to the power of negative 9 plus 1, which is 4 to the power of negative 8. So this is the left side. So I'm going to write right here, 4 to the power of negative 8. Now over here, I'm doing the right side. So 4, I forgot to write negative 3 here. So negative 3 minus 5. Negative 3 minus 5, that's the same as 4 to the power of negative 8. And I'm going to write 4 to the power of negative 8. We see that it's the left side is equal to the right side, or vice versa, the right side is equal to the left side. So it's true. So this is how we apply exponential function one-to-one property. We set the bases equal to each other and therefore solve the exponents by setting the left exponent equal to the right exponent, or the right exponent equal to the left exponent, and then solve for the variable.